All right, Jonathan, what do we have for tech history this week? June 14th through the 20th.
Yes, for this week, we are going to cover the first one, June 14th. Charles Babbage unveils difference engine.
The difference engine. What is the difference engine?
He called it the difference engine.
The first example of a mechanical computing engine. Oh, I remember this guy.
Really?
Yes. Okay. Oh man, this guy. So he goes to Parliament, the European government, and he says, I have this great idea. It's an analytical engine. We'll be able to analyze numbers. And they said, great. He says, all I need is $1 million. And they said, okay. So they funded him. Halfway through building this analytical engine, or is it the other way around? Hang on. He might have, I don't know if he did this first or I think he did this first, because then he also came up with something different. And he stopped working on this. He blew through the $1 million, and then he went back to Parliament and said, I got a better idea. I need another $1 million. And it was like some kind of computer programming. And he's like, he goes, this is going to go beyond analytics. We can actually program. And they're like, okay, but what happened to the analytic engine? And he goes, no. He goes, we're not going to do that anymore. We're going to start working on this other thing. And so Parliament says, like, no, go finish that engine, and then we'll talk about your next great idea. So he ended up blowing through the $1 million. And I don't know if he only finished the design but didn't finish the analytical engine. First example. Oh, okay. You know what? I got it all wrong here. First example of mechanical computer machine. The British government funded a difference engine, which Babbage never really actually completed. However, Babbage's design for the difference engine and his later analytical engine spurred future designs of working mechanical computers. So yeah, so he started with the difference engine and then never finished it, and he came up with the difference engine, and then later came up with the analytical engine. So yeah, he took his $1 million, burned through it. But I mean, this work right here actually led to what computers do today. So,
yeah.
Pretty cool. I couldn't imagine what a computer would be like in 1822.
Yeah. Seems pretty like caveman-y. Kind of like knobs and things that turn like.
Yeah. It's crazy. What else we got?
Next, we have Gates announces transition from Microsoft.
Oh, this is when Steve Ballmer became CEO.
Oh, okay.
Yeah. So in 2006, he's like, I've had it. I'm out. But I think he actually, he wanted to focus more on the Bill and Melinda Gates Foundation, because he wanted to be a philanthropist.
Mm-hmm.
But I think he still stayed as part of the board. So up until recently, with the big scandals that he's been facing, Yeah, it's too bad. I mean, philanthropist, he's done a lot of good things for a lot of people in need. But yeah, he's caught up in a scandal right now. And I think the board asked him to step down.
Oh, wow.
Yeah. So it kind of sucks. So,
all right.
What else do we
On
got?
June 17th, we have the first 2 video games copyrighted
On your
my birthday.
Oh, I remember Asteroids.
And Lunar Lander. That's freaking awesome.
I don't remember Lunar Lander, but I do remember Atari's Asteroids.
That's cool. They were copyrighted on my birthday.
Yeah, like 13 years before you were born.
Maybe that's why I want an arcade machine so bad.
You know what's funny about these big arcade machines is that most of them are hollow inside. The biggest component in there was the TV, the CRT monitor.
It's because
So
they
they
had
had
the big back on the back.
exactly, yeah, yeah. And then I guess the box to hold the coins and stuff. But you know what we used to do in order to get free games?
But
There was a couple of different ways that you can do this. One of them was that you can get those big D batteries, and you would grab the battery and you would just bang it up against the where the coin slot would be. And for some reason or other, between your hand and the spark that it would make, it would trigger something and just start giving you free credits
no,
to play.
that's
The other
cool.
thing, the other thing that we used to do, not we, I never, I used to see guys. I was never that smart to really take free games. Was tying a string to a coin, and what you do is you lower the coin down just enough so that it would trigger the lever to give you a free credit, and you just sit there and you just pop the coin back and forth on the string, and the credits would just show up. And so eventually you could just let it go. There was a third way. What happens is that when you put the coin in from the top, there's something that measures the height and the weight and the width of the coin
Mhm.
to make sure that they were quarters, because that's what these games took, right? They were quarters. So once it got past that, then it would drop into what would trigger, there would be like a lever or something that it would trigger to give you the credit. So what we used to do, we take pennies and we flip them through the coin return so that it would bypass the measuring and weight and we'd flip it, from the bottom, and it would like go in and just trip the.
That's cool.
So we used to sit there and just, take $1, or get $1 worth of a roll of pennies and get 100 credits, like just sit there and just flip them from under. But what sucked is that when the guy would show up to collect his quarters, all he found was pennies. So, they got smart. They ended up like making it harder. I think what happened was that they would move the slot up higher so that your fingers couldn't reach it. We could like, so they caught on to that one pretty quick, but it lasted for a while. It was pretty fun. Cool. What
All
else?
right. Next, we have Microsoft introduces BASIC for 8086.
Can you imagine? This is what you would be programming in.
What is it?
Basic. Basic was a programming language.
Oh, wow.
Yeah, it was called Basic. Yeah, it started off with oh gosh, let's see. I wonder if there's a basic. Old basic REPL. Okay, here we go. Here's an example of what it would look like. So that's basically what it would look like.
All right.
So instead of your curly braces and stuff like that, you would do sub and sub. So that would denote the beginning and ending of a. And then you have if, else, and if instead of the curly braces.
Yeah.
So it was a little bit more verbose and a little bit more expressive, I guess. And so I never knew what this dim was. What is this dim? But that's, I guess, how you would create create some kind of variable.
Interesting.
Yeah. But even before then, there was a different type of, let's see if we can see. Here we go. Let's see if we got any examples. Yeah. So what would happen is that you would have to write line numbers. So it would be 10, 20, 30, 40, 50, 60. And then these would be your commands. Okay.
Mm-hmm.
Now, you could have simply just done 1, 2, 3, 4, 5, 6, 7. But the problem is that if you forgot to write something in between 10 and 20, then you had to go and create all new line numbers. So if, say, for example, you didn't have the 10, 20, 30, 40, 50, 60, and you just had 1, 2, 3, 4, 5, 6, when you insert a line between 1 and 2, then 2 becomes 3, 3 becomes 4, 4 becomes 5. So you have to go renumber your lines.
Mm-hmm.
So on larger programs, if you needed to insert a line, you would insert line 15.
Mm-hmm.
And so as long as those numbers were there, that would be the sequence which the computer would process them.
Oh.
But that was basic on the Commodore 64. Yeah. And then they came up with the more expressive version of BASIC. Cool.
All right.
What else?
One more.
One more.
All right. Let's do the SEAC machine dedicated.
National Bureau of Standards dedicated the SEAC, Standards Eastern Automatic Computer in Washington. The SEAC was the first computer to use all diode logic and technology more reliable than vacuum tubes. Yeah. It was the first stored program computer complete in the United States. Magnetic tapes, external large storage unit, stored programming information, coded subroutines, and numeric data. Well, this is interesting in 1950 because what would happen is that prior to this, you would have to write your program in this deck of cards. And you would hand these cards over to another person. And that person was called the compiler. So you were the programmer and you handed your deck of cards to the compiler. And then the compiler would compile it and then give you the results of your program or the error code. And if something went wrong, then you had to go back to the drawing board and figure out what was wrong based on the error code. Sometimes it would take a month for the compiler to give you your results back.
Oh, wow.
And so with this right here, you were able to store the program on the computer and run it as a subroutine. So this was a lot more efficient.
Definitely.
So kind of cool.
Cool.
Pretty cool.
That's what we have in tech history this week.
Excellent. Until next time.